Hi folks, this is Calc 3 Quiz 22. We're given a surface S parameterized as follows. We're asked to, in part A, find the partial derivatives and the cross product. So this takes us back. How do we find? Or what does this mean? This is the partial derivative with respect to u of the vector valued function ruv. And just like in chapter 12, the calculus of vector valued functions goes component wise. So I'm just going to take the derivative of each component with respect to u. So I'm going to get cosine v sine v negative 2u. Similarly for rv, that's the partial derivative with respect to v of this function. It's going to go component wise as well. I'm going to have negative u sine v, u cosine v, and 0. And now for the cross product. What does this mean? This means I just take the cross product of these two vectors. So I've got an I hat, j hat, and k hat. And into the I put the x components, y components, and z components. So I put cosine v, sine v, negative 2u, negative u sine v, u cosine v, 0. Let's see what I get. If I wipe out the row and column the I is in, I get a 0 minus a negative 2u times that. So I'm going to get a positive 2u squared cosine v. With the j hat, wipe out the row and column the j is in. I get a 0 minus, this times this is a positive, that's a 2u squared sine v. But I make that negative, so I'm going to get a positive then, 2u squared sine v. Finally, wipe out the row and column the k hat's in. I get u cosine squared v plus u sine squared v. That gives me u. So that'll do it for part A. Alright, for part B, we're first charged with the task of showing this point is on the surface. So how do I do that? Well, the way a point gets on the surface is there's a value of u and v whose x, y, and z component match the x, y, and z coordinate here. So in other words, I need to find u and a v in this range of numbers so that r of u v is negative 1 square root 3, 5. So let's write down what that means. The x coordinate is u cosine v. That has to work out to be negative 1. The y coordinate is u sine v. That has to work out to be radical 3. The z component is 9 minus u squared. Oops. 9 minus u squared. And that has to work out to be 4 or 5. So I can work here. I get u equals plus or minus, or u squared rather equals 4, which means u is plus or minus 2. But I go back and look out to see where u lives. U is living between 0 and 3, so that means I'm going to pick the positive 2. Once I have positive 2, I can substitute that back into here. I'm going to get 2 cosine v is minus 1, which means cosine of v is minus 1/2. And here I'm going to get 2 sine v is radical 3, which means sine v is square root 3 over 2. Now these two things together give me that v is 2 pi over 3. Okay, so r of 2 comma 2 pi over 3 is the vector negative 1 radical 3, 5. So the point negative 1 radical 3, 5 is on the surface S. Okay, so we know that 2 comma 2 pi over 3 is the UV pair that gives us the point we're looking at. And then from part A we have this as the cross product RU cross RV. We're asked to find an upward pointing normal. And so it's either going to be RU cross RV or it'll be its opposite. So let's check it out. If I take RU cross RV at the point then 2 comma 2 pi over 3, substitute that in. Everywhere I see a U, I plug in a 2. Everywhere I see a V, I put in 2 pi over 3. So 2u squared is going to be 8. The cosine of 2 pi over 3 is negative 1/2. So 8 times negative 1/2 is negative 4. I get 8 times the sine, which is radical 3 over 2. So I get 4 radical 3, comma 2. Now how do I know this is upward? Well, upward means positive z component. And so that'll do it for part B.